All right, section 3.5 is talking about transformations of functions. So if we look over on the calculator over here, the blue graph is y equals x squared. So that's just that blue graph right there. I guess they all go at once, but that's y equals x squared. 2. Okay. Anyway, sorry. So that's y equals x squared. The red graph is y equals x squared plus 3. So if you can see from the blue to the red, it's going up. The red is 3 higher, 3 higher. The green is down from the blue. So that -2 moved it down. And the pink is up 5. So what this number does to an equation is it translates or slides. We also call them a vertical shift. So when you're adding a number, you're going to move the graph up C. When you're subtracting a number, you're going to move the graph down. So this function right here is our parent function for this graph. To figure out the parent function, if it's not one you recognize, you can go back and look at this sheet that I kind of talked about in 3.1, and you're going to say, hey, that one is the v, so the parent function must be y equals absolute value of x. And then your parent domain and range are right there. So our parent function would be absolute value of x. And then our new graph moved up 2, because there was a 2 right there on the grid. So our translation is up 2, meaning our new equation would be the absolute value of x plus 2. Horizontal shifts are the same thing, except they're shown inside the parentheses. And whenever you're doing anything in the parentheses like this, you do the opposite of what you would expect. So when it says plus C, you're really moving left. And when it says minus, you're really moving right. And the difference is, up here, it is not in the parentheses. Down here it is. So our parent function for this graph looks like this, with a dot at the end. So if we go back to that sheet, this one's similar, but it has an arrow, so it's not that. So instead, it's going to be this one, where we have square root of x. So my parent function is the square root of x. That blue one has moved to the right. And by this 2, we know it went over 2. So we treat that radical just like it was parentheses. So in the parentheses, or in the radical, we would write x minus 2. Now, lots of equations have both the horizontal and the vertical. So each number is going to give its own movement. So this plus 2 is going to tell us that we go left 2. And this minus 6 is going to tell us that we go down 6. So that absolute value graph would have slid left 2 and down 6. For b, we have our radical, our square root. So we're going to go right 2, and then the plus 8 tells us up 8. So you can just describe both of those that way. Let's look at a bunch all combined and the different things we can do with them. So this graph is a U. I didn't really trace it well, but, So we have a U. If we go back to that function graph, that U is the square. So it'd be y equals x squared. And then our domain is negative infinity to infinity. Our range is 0 to infinity. So our parent domain, we just said, was negative infinity to infinity. And the parent range was 0 to infinity. Now if we look at the red graph on here, the center is right here. So that means we've moved right 1, which is that. And we've gone up 2, which is that. And the domain of that graph is still negative infinity to infinity. But now we have an absolute minimum So our range is 2 to infinity. All right, so now let's look at the green graph. So by this little 3 here in our equation, or if we find the graph that it looks like, we have a cubic where the parent, domain, and range are negative infinity to infinity. And then we go up and down forever and left and right forever. So our translated graph, domain, and range is the same. Now let's look at the blue one, or purple, I guess. So that's another one of those square root graphs. You have a radical here, or you match it to the graph. And the domain of those, domain and range, are both 0 to infinity. So the parent is 0 to infinity, 0 to infinity. Then if we look at this new graph, the domain starts at 2, and the range starts at -3. So how did our translations affect the domain and range? Well, if you look at all the pieces, anything that was negative infinity to infinity is still negative infinity to infinity. Those didn't change. The ones that changed were the ones that started limited. So if we started at 0 and we moved it up 2, it would make sense that our range went to 2. If we started at 0 and we went down 3, it would make sense that our range went down 3. And then the same thing with our domain. If we shift our domain, we shift it. Negative to infinity, you can't really shift. So that's where those come in. Symmetry is another way to describe shapes. A function with even symmetry is reflective or symmetrical at the y-axis. And then a function with odd symmetry is rotational at the origin, 0, 0, meaning you can spin it. So that's how visually you can tell. Then algebraically, if the negative and positive values of the same number, so like -2 and +2, are plugged in and you get the same answer, that would be even. If the negative value is the same as the opposite, it's odd. Looking at the points, even just changes A. It's the opposite of A, and then odd is the opposite of both. So those are some different ways to think about it. Now I'm going to show you algebraically how to prove it. So to decide if it's even or odd, it's easier to start with even. And what that means is you're going to plug in -x wherever you see an x. So here I would say 8 times -x to the 4th minus 3 times -x squared. Now -x to the 4th means -x times -x times -x. So those cancel, and we end up positive. So this would be 8 times positive x to the 4th. And then minus 3, so 2 negatives cancel, so it ends up staying like that. Now if you compare f of -x to f of x, they're the same. So when f of x equals f of -x, that is even. That means if I were to graph that equation, it would be symmetrical at the y-axis. I could fold it in half. All right, let's look at this one. So we're going to try plugging in -x. So 6 times -x cubed minus 9 times -x. So -x, 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 those cancel. There's one left. So this becomes negative. And then a negative times a negative is a positive. So if we compare those, they are not the same. F of x does not equal f of -x, so it's not even. Now, to do odd, we look at negative f of x. So that's saying, hey, take the whole equation and make every piece negative. So positive 6x cubed becomes negative, and negative 9x becomes positive. Now, if we look at the blue and the green, those are the same. So f of negative x equals negative x. So this one's odd, meaning it'll be rotational. Let's look at one more. So we'll start with our even. So 3 times negative x squared plus 5 times negative x gives us 3x squared minus 5x. Those are not the same, so it's not even, because one has a plus and one has a minus. If I do negative f of x, I make this positive and I make this negative. But it's also not odd because one of these is positive and one of these is negative. So this one's neither odd or even. Now, if you have to prove it, you have to do the math out and show me. If it doesn't say prove, then you can just look at the exponents. Notice here, 4 and 2 are even. So if both exponents are even, it's even. If there's no exponent, it's a 1. So here, if both exponents are odd, it's odd. And if they're different, because that one's even and that one's odd, then it's neither. So you don't have to do the math out necessarily to know the difference. All right, the last part of this transformation section is looking at stretches. So we're going to talk about how we stretch it horizontally and stretch it vertically instead of just slide it like we did at the beginning. So an equation would look like this, k times f of x. It's just when you take any number and multiply it by the equation. So in a regular equation written out, it could look something like this. This is just saying, hey, we're taking that whole equation and multiplying it by 3. That's how that would look. The rules are, your x-intercepts are going to stay the same because 0 times anything is 0. You take the y value of any point and multiply it by k. Your x value stays the same and you have a new point. So f of x is that graph right there. 2 times f of x, here's how we find it. So our y-intercepts stay the same, those are the blue points. This point up here has coordinates -6, 4. So I'm going to take the y and multiply it by 2. So -6 stays the same, 4 times 2 is 8. I'm going to graph this new point at -6, 8. Now let's do this point. That green point is -4, -2. X stays the same. We do -2 times 2 and get -4. So that new point is -4, -4. Some people can look right at the graph and say, hey, that y value is 4. 4 times 2 is 8 and put it up there. Other people need to do it out. That's up to you. This y value is 2. 2 times 2 is 4. So if I connected all of those points, I forgot this one, 2, 4, okay. If I connect all of those new points, now my shape is all stretched out. So the parts that were positive got more positive, the parts that were negative got more negative. If it's a fraction, we're going to do the same thing. We're just going to squish it instead of stretch it. So our y-intercepts are still going to stay the same. But now this point, we do 4 times 1/2 and get 2. For this point, we do -2 times 1/2 and get -1. 2 times 1/2 is 1. 4 times 1/2 is 2. And again, you can do all the points out or you can do it just looking. That's up to your brain, but that one is squished. So that's our vertical stretching or squishing. Horizontal, same idea, but we're going to be in the parentheses. So this time our y-intercept stays the same. And just like with our shifting, we do the opposite. So we're going to do the x value divided by k and keep our y the same. So f of x is the pink. This point right here is negative 8 comma 4. So for 2x, I'm going to do negative 8 divided by 2, which is negative 2. Y stays the same. So this point becomes negative 4, 4. This point down here is negative 4, negative 4. X value divided by 2 becomes negative 2. That stays the same, so we go negative 2, negative 4. And again, you can keep going, or you can do it in your head. So 4 divided by 2 is 2. 7 divided by 2 is 3.5. And then we have our new shape, which is squished. So it's the opposite. Our big number is going to squish, and now our fraction is going to stretch it. So here, our x value is going to be divided by 1/2 this time. So this becomes negative 16. This becomes negative 8. And then 4 becomes 8. And 7 becomes 14. And we get all stretched out. So that's how the multiplying works. You have to do it coordinate by coordinate. You can't just slide. Reflecting. Now, technically, these are the same as what we just talked about with our stretching. And you can think about it that way and say that negative f of x is just saying negative 1 times y. And f of negative x is x divided by negative 1. Either of those things is fine how you think about it. But if all you have is the negative, you can just flip your shape. If the y is negative, you do it over the x-axis. So it's kind of the opposite of what you would think. So here it says the y is negative. So we're going to flip it over the x-axis. So positive 2 becomes negative 2. Negative 4 becomes positive 4. Negative 2 becomes positive 2. And we flip that shape. If we do it over the y-axis, it's negative on the inside. So negative 2 becomes positive 2. Positive 6 becomes negative 6. And that one will stay because it's 0. So that one flips over the y-axis. Again, some people thinking about this differently. Some people treat it just like the stretching. That's up to you. When you have a whole bunch of transformations combined, you follow order of operations. So we're still going to do whatever's in the parentheses first. Then we'll do our multiplying. Then we'll do our up and down if we have it. Some people can look at this and do all 3 parts in their mind at once. For example, they can take this point and move it right 4. And then say 4 times negative 3 is negative 12. And then go up 5. And they can do the same thing with this point, right? 4 times negative 3, up 5. And they can plot the shape like that. You are welcome to do it that way if you want. Other people need to do it step by step. So the way that would look is I'm going to go right 4. So I'm going to take each of these dots and move them right 4. Then I'm going to take all the y's and multiply by negative 3. This is going to go way off the paper, so I'm not going to do that one. But 4 times negative 3 is negative 12. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. 1 times negative 3 is negative 3. 0 times negative 3 is 0. And these ones are going to flip. Then I go up 5. So each of those dots moves up 5. And I can draw my final one. So whether you do it all at once and just plot the final points, or you do it in steps, you get the same final answer. But if you draw the steps, make sure I know which one your final answer is. That's all I really need to know about that. So that is what is needed from 3-5. Let me know if you have any questions.